Hello everyone. Today the content we are going to learn is the structure of high voltage switchgear. Through this study, students should master the main content and operational characteristics of high voltage switchgear, thereby enabling accurate and standardized operation and maintenance of high voltage switchgear. Through learning, we will develop good professional qualities and teamwork skills. The key and difficult points of this lesson are the main structure and operational characteristics of high voltage switchgear. So, what exactly is high voltage switchgear and how does it operate? High voltage switchgear refers to electrical equipment primarily based on circuit breakers used in power generation, transmission, distribution, power conversion, and consumption in power systems to perform functions such as switching, control, or protection. It means that manufacturers assemble relevant high and low voltage electrical appliances, including control devices, protection devices, measuring devices, as well as busbars, current carrying conductors, and insulators into enclosed or open metal cabinets according to the requirements of the primary electrical wiring diagram. This serves as a device for receiving and distributing electrical energy in the power system. So, what is the structure of high voltage switchgear composed of? Let us watch a video below. By watching the video, we can see that high-voltage switchgear is composed of two main parts, a fixed cabinet and withdrawable components. First, let's look at the cabinet. The cabinet adopts an assembled structure, connected with rivet nuts and high-strength bolts. Therefore, the assembled switchgear can maintain dimensional uniformity. The switchgear's enclosure and partitions are made of aluminum zinc-coated steel plates. The entire cabinet not only has high precision, corrosion, and oxidation resistance, but also high mechanical strength and an attractive appearance. The switchgear is divided by partitions into a compartment for withdrawable parts, a busbar compartment, a cable compartment, and a relay and instrument compartment. Each unit requires good grounding. Next, let's specifically analyze the functions of the above 4 parts. The busbar compartment is arranged at the upper rear of the switchgear. It serves to install and arrange the 3-phase high-voltage AC busbars and to connect with the stationary contacts via branch busbars. All busbars are plastic insulated with insulating sleeves. When busbars pass through switchgear partitions, they are fixed with busbar bushings. If an internal fault occurs, the arc can be limited from spreading to adjacent cabinets, and the mechanical strength of the busbars can be ensured. The cable compartment can install current transformers, grounding switches, surge arresters or overvoltage protectors, and cables and other auxiliary equipment. Its bottom is equipped with slotted removable aluminum plates to facilitate on-site construction. The panel of the relay and instrument compartment is equipped with microprocessor-based protection devices, operating handles, protection outlet plates, meters, status indicators, etc. The relay compartment contains terminal blocks, DC power switches for microprocessor protection control circuits, energy storage motor working power switches for microprocessor protection, and secondary equipment with special requirements. The withdrawable part compartment has specific rails installed in the circuit breaker compartment to allow the circuit breaker truck to slide and work inside. The truck can move between the service position and test position. So, what are the service position and test position? This requires understanding the 3 positions of the switchgear truck. The switchgear truck includes the service position, test position, and maintenance position. The service position is also called hot standby. It means all components in the switchgear are in working condition, except that the circuit breaker is not closed. This state is called hot standby. Lines that need to be closed immediately should be in hot standby. Those with automatic closing also need to be in hot standby. Motor switches started by on-site button operation also need to be in hot standby. The test position is when the circuit breaker is pulled out to the movable seat, but the circuit breaker is disconnected from the primary system, completely disconnected. It is a position where the safety distance between primary contacts can be ensured. The secondary plug is still inserted into the socket. As long as the operating power is switched on, the secondary circuit and circuit breaker operation can be tested for normalcy. The maintenance position is when the circuit breaker is pulled out of the cabinet. The partition or shutter for the truck's primary contacts is installed on the rear wall of the truck compartment. When the truck moves from the test position to the service position, the partition automatically opens. When moving in the opposite direction, it closes completely. This ensures that operators do not touch live parts, improving the safety performance of the equipment. The truck compartment can not only accommodate circuit breakers but also PT trucks, metering trucks, and isolation trucks. Below, taking a vacuum circuit breaker truck as an example, the truck compartment includes upper terminals, lower terminals, secondary wiring plugs, insulating sleeves, with vacuum interrupter contacts inside, and the truck frame. Next, let's look at the classification of high-voltage switchgear and the characteristics of different types. According to its characteristics, it can be divided into metal-enclosed, metal-clad, metal-enclosed box type, and SF6 gas-insulated switchgear, GIS. According to the installation method of the circuit breaker, it can be divided into fixed type and truck type. According to the cabinet structure, it can be divided into open type and enclosed type. According to the installation location, it can be divided into outdoor and indoor types. No matter which type of high-voltage switchgear, during operation, it has the following 5 characteristics. 1. When the vacuum circuit breaker truck in the high-voltage switchgear is closed in the test position, the truck circuit breaker cannot enter the service position. 2. When the grounding switch inside the high-voltage switchgear is closed, the truck circuit breaker cannot enter the service position or close. 3. When the vacuum circuit breaker inside the high-voltage switchgear is closed and operating, both the front and rear doors of the cabinet are mechanically interlocked with the grounding switch on the cabinet door. 4. When the vacuum circuit breaker inside the high-voltage switchgear is operating and closed, the grounding switch cannot be closed or engaged. 5. When the vacuum circuit breaker inside the high-voltage switchgear is operating and closed, the truck circuit breaker cannot be withdrawn from the service position. It is important to note that staff operating high-voltage switchgear must be familiar with the above 5 characteristics. Operate according to specifications to prevent safety accidents. The above is about the main structure and operational characteristics of high-voltage switchgear. After class, please use your spare time seriously to think about and complete the following questions. That's all for this lesson. Thank you for watching. Goodbye.